This video is based on official NTSB investigative reports and documented evidence. The story you are about to hear represents one of aviation's most preventable tragedies, a case where cost-cutting maintenance practices and regulatory failures created a hidden mechanical time bomb that claimed 88. Alaska Airlines Flight 261, en route from Puerto Vallarta to San Francisco, glides silently and safely at 31,000 feet over the Gulf of California. The McDonnell Douglas MD-83, registered N963AS, carries 83 passengers and 5 crew members on what should have been a routine winter holiday flight. Among the passengers are families returning from Mexican vacations, business travelers, and those whose lives will be intertwined with tragedy due to a mechanical failure they could never have imagined. In the cockpit, experienced pilots Captain Ted Thompson and First Officer Bill Tansky are managing what appears to be a perfectly normal flight. Inside the aircraft's tail section, a vital component was slowly wearing down over time. The horizontal stabilizer screw, which controls the aircraft's pitch, was slowly self-destructing due to inadequate maintenance and lubrication practices. This is the story of Alaska Airlines Flight 261, how a single worn part led to an impossible flight control emergency, and how shortcuts taken in maintenance transformed a routine flight into a fight for survival that the two heroic pilots could not win. The investigation will expose systemic failures in airline maintenance oversight and show how regulators failed to protect passenger safety. Alaska Airlines Flight 261 is operated by a McDonnell Douglas MD-83, representing an evolution of the popular DC-9 design. Delivered in 1991 and registered as N963AS, the aircraft has served Alaska Airlines for 9 years, accumulating 26,277 flight hours and 14,315 cycles in commercial service. The MD-83's distinctive T-tail design places the horizontal stabilizer at the top of the vertical tail, creating an efficient configuration for the twin-engine aircraft. This horizontal stabilizer, a 40-foot wide surface, controls the aircraft's pitch angle via an advanced mechanical system. Unlike conventional aircraft that use small trim ailerons, the MD-83's entire horizontal stabilizer moves to control pitch trim. This system requires a tremendous mechanical advantage achieved through a screw assembly located in the aircraft's tail cone. The screw assembly system consists of a steel screw that rotates through a bronze nut, converting rotational motion into linear motion that positions the horizontal stabilizer. When this system functions properly, it provides precise control over the aircraft's longitudinal stability. 53-year-old Captain Ted Thompson is experienced enough to fly MD-80s with over 4,000 hours of flight experience. His background as a former Air Force pilot makes him sufficiently experienced for demanding flight operations. 57-year-old First Officer Bill Tansky serves as a pilot with over 8,000 hours of flight experience on MD-80s. His U.S. Navy aviation background complements Thompson's experience, creating a highly qualified cockpit crew. The aircraft's maintenance records show routine inspections and services, but hidden within is a mechanical disaster slowly and invisibly developing. The jack screw assembly of Alaska Airlines Flight 261 harbors a fatal secret stemming from decisions made at Alaska Airlines maintenance facilities. In 1997, during a C-check inspection, mechanic John Liatine identified excessive wear on the jack screw system, determining the end clearance to be 0.040 inches, the maximum allowable limit. Realizing the safety implications of continued operation, Liatine recommended immediate replacement of the worn jack screw assembly. His professional assessment, based on manufacturer specifications and safety protocols, required the aircraft to be grounded until repairs were completed. However, Alaska Airlines management rejected Liatine's recommendation. A second inspection team claimed that the 0.033-inch end clearance was within limits, allowing the aircraft to return to service with the worn parts still installed. This decision represents a fundamental failure in maintenance oversight and safety culture. The jack screw assembly, designed as a single critical point of failure component, was allowed to continue operating despite clear evidence of excessive wear. The controversy surrounding Liatine's recommendation extends beyond a single maintenance decision. Alaska Airlines placed the technician on administrative leave in 1999, and he subsequently filed whistleblower complaints with federal authorities about the airline's maintenance practices. Unbeknownst to the 88 people on Flight 261, their aircraft had a screw jack assembly that had operated 3 years longer than its recommended replacement interval. Each flight cycle placed additional stress on the worn threads, bringing the system closer to a catastrophic failure. This led to a mechanical failure that pushed the limits of pilot skill and aircraft design. The jack screw assembly's deterioration accelerates due to Alaska Airlines' extended lubrication intervals, a cost-saving measure that proves catastrophically short-sighted. The airline extends lubrication from the manufacturer's recommended 650 hours to 8,000 hours, more than 12 times the original interval. This extension, approved by the FAA, reflects a dangerous trend in airline maintenance where economic pressures override safety considerations. The jack screw assembly requires frequent lubrication to prevent metal-on-metal wear between the steel screw and bronze nut. Without proper lubrication, the bronze nut begins wearing away microscopic amounts with each trim movement. Over thousands of flight hours, this wear accumulates until the nut's threads can no longer hold the jack screw under the tremendous loads placed on the horizontal stabilizer. Investigation reveals that the lubrication system itself fails due to blocked grease fittings. The passages designed to deliver lubricant to the critical wear surfaces become clogged with dried residue, preventing proper maintenance even when attempted. Alaska Airlines maintenance personnel either fail to recognize these blocked fittings or inadequately clear them during service intervals. The result is continued operation of an essentially unlubricated jack screw assembly under the extreme loads of commercial flight operations. Each flight adds stress cycles to the wearing threads. Each trim input from the pilots accelerates the deterioration. The jack screw assembly becomes a mechanical time bomb, counting down toward total failure through metal fatigue and inadequate maintenance. By January 2000, the bronze nuts threads have worn to a critical state where only minimal material strength prevents complete failure of the flight control system. Before we continue with this tragic sequence, we want to thank our viewers who follow through the pilot's eyes. These investigations into maintenance-related accidents help us understand how economic pressures can compromise aviation safety. Your subscriptions help us research these technical aviation stories. Flight 261 departs Puerto Vallarta's tropical paradise at 1:37 p.m. Pacific Time, bound for San Francisco with beautiful weather and light winds. The MD-83 carries vacationers returning home after Mexican holidays, unaware they're aboard an aircraft with a critical mechanical failure developing in its tail. First Officer Tansky flies the departure manually, climbing through 6,200 feet before engaging the autopilot for the cruise portion of the flight. The aircraft systems respond normally as the crew manages routine navigation and communication tasks. For over an hour, Flight 261 operates without any indication of the mechanical disaster brewing within the jack screw assembly. The autopilot maintains the aircraft's attitude using small trim inputs that place additional stress on the already compromised threads. As the aircraft climbs toward its cruising altitude of 31,000 feet, passengers settle in for what should be a peaceful flight over Mexico's stunning coastline. Flight attendants prepare for meal service while the experienced cockpit crew monitors the aircraft's progress. The jack screw assembly continues its deadly countdown, each trim input wearing away more bronze material from the critical threads. The system operates within normal parameters, providing no warning to the crew about the catastrophic failure approaching. At 23,400 feet, the inevitable occurs. The worn threads finally give way under the tremendous loads placed on the horizontal stabilizer during normal flight operations. At 23,400 feet above the Gulf of California, the decades of maintenance failures and regulatory oversight collapse into a mechanical emergency. The autopilot trim warning illuminates as the horizontal stabilizer stops responding to commands, beginning Flight 261's transformation from routine airline service into an impossible flight control crisis. Captain Thompson and First Officer Tansky immediately recognize they face a significant problem. "We have a jammed stabilizer," Thompson reports to air traffic control. Though neither pilot fully understands the scope of their emergency at this point, the crew begins troubleshooting procedures, attempting to regain control of the trim system through manual inputs and electrical switching. However, their efforts cannot overcome the mechanical reality. The jack screw assembly has lost its threads, leaving the horizontal stabilizer essentially disconnected from pilot control. Without trim control, maintaining level flight becomes extremely difficult. The pilots must use constant elevator pressure to prevent the aircraft from entering uncommanded attitudes, turning routine flight into a physical struggle against aerodynamic forces. As the situation develops, Flight 261 begins an uncommanded nose-down attitude that the crew fights with increasing elevator back pressure. The aircraft descends from 31,000 feet toward 24,000 feet. Despite the pilot's efforts to maintain altitude, the crew declares an emergency and requests diversion to Los Angeles International Airport, recognizing their need for immediate landing at a major facility with emergency services. Their professional response reflects years of training, though no training can prepare them for the mechanical failure they face. The battle for control of Flight 261 has begun, testing pilot skill against impossible mechanical odds. With the horizontal stabilizer locked in a nose-down position, Captain Thompson and First Officer Tansky begin an extraordinary demonstration of airmanship under impossible conditions. They managed to regain some control by using manual elevator inputs and thrust adjustments, temporarily stabilizing the aircraft. The crew attempts various procedures to restore trim functionality, including electrical switching and manual reversion techniques. However, the complete failure of the jack screw threads makes these efforts futile. There is simply no mechanical connection between the cockpit controls and the horizontal stabilizer. Flight 261's pilots discover they can influence the aircraft's attitude through coordinated use of engine power and elevator control. Increasing thrust helps raise the nose, while reducing power allows descent. This technique requires constant attention and perfect coordination between both pilots. Despite their desperate situation, the crew maintains professional communication with air traffic control and cabin crew. Captain Thompson authorizes First Officer Tansky to inform passengers about their emergency while downplaying the severity to prevent panic. The aircraft's flight path becomes increasingly erratic as the pilots struggle with manual control. Flight 261 experiences altitude excursions and attitude changes that challenge the crew's ability to maintain safe flight parameters. In a desperate attempt to regain control authority, the crew considers flying the aircraft inverted, hoping the reversed aerodynamics might provide better control characteristics. This unprecedented decision reflects both their skill and the hopelessness of their situation. The pilots coordinate their efforts with remarkable professionalism, sharing control responsibilities while managing emergency procedures. Their airmanship represents the highest standards of commercial aviation under conditions no training could anticipate. Despite the crew's extraordinary efforts, the mechanical reality of Flight 261's jack screw failure ultimately overcomes even the most skilled airmanship. The horizontal stabilizer, locked in a nose-down position, creates aerodynamic forces that no amount of pilot skill can permanently overcome. At 4:19 p.m. Pacific Time, Flight 261 enters its final, uncontrollable dive toward the Pacific Ocean. The aircraft descends at over 10,000 feet per minute in an inverted attitude as the crew fights desperately to regain control. Captain Thompson and First Officer Tansky continue their coordination efforts until the very end, attempting every possible technique to arrest the descent. Their professional communication continues even as they recognize the inevitability of impact. The cockpit voice recorder captures the final moments of two professional pilots who refuse to abandon their responsibilities despite facing impossible circumstances. Their dedication to their passengers and aircraft represents the highest traditions of commercial aviation. At 4:21 p.m., Flight 261 impacts the Pacific Ocean approximately 2.7 miles north of Anacapa Island, California. The tremendous impact forces destroy the aircraft completely, killing all 88 people aboard instantly. The crash creates a debris field scattered across the ocean floor, but preserves critical evidence that will allow investigators to determine the exact cause of the accident. The jack screw assembly, recovered from the wreckage, tells the complete story of maintenance failure and regulatory oversight. Captain Thompson and First Officer Tansky receive posthumous recognition for their heroic efforts to save Flight 261, earning the Airline Pilots Association Gold Medal for heroism. The NTSB investigation into Flight 261 uncovers devastating evidence of systemic maintenance failures and regulatory negligence. Recovery of the horizontal stabilizer from the Pacific Ocean provides investigators with the smoking gun, a jack screw assembly with completely worn Acme nut threads. The bronze nuts threads, designed to support tremendous loads, have worn away to nothing more than a coiled slinky of metal wrapped around the steel jack screw. Metallurgical analysis reveals years of progressive wear caused by inadequate lubrication and excessive operating intervals. Investigators discover that Alaska Airlines extended maintenance intervals far beyond manufacturer recommendations, with FAA approval. The lubrication schedule increased from 650 hours to 8,000 hours, while inspection intervals stretched from 7,200 to 9,550 flight hours. The investigation reveals blocked grease fittings that prevented proper lubrication even during scheduled maintenance. The critical wear surfaces operated essentially dry for extended periods, accelerating the deterioration that led to complete thread failure. Alaska Airlines' maintenance culture comes under intense scrutiny. The NTSB documents widespread deficiencies in the airline's oversight programs and finds that mechanics who identified problems faced retaliation for their safety concerns. The FAA's approval of extended maintenance intervals represents a fundamental failure of regulatory oversight. The agency failed to ensure that cost-saving measures maintained adequate safety margins for critical components. The investigation concludes that Flight 261's crash was entirely preventable through proper maintenance practices and adequate regulatory oversight of airline operations. As we conclude this investigation into a preventable maintenance tragedy, we thank our viewers who follow through the pilot's eyes. These studies of regulatory failures help us understand how economic pressures can compromise aviation safety. Your support allows us to research these important aviation safety stories. The Flight 261 investigation triggers fundamental reforms in aviation maintenance oversight and airline accountability. The NTSB issues 24 safety recommendations addressing jackscrew inspection procedures, lubrication requirements, and regulatory oversight. Alaska Airlines faces intense scrutiny and implements comprehensive maintenance program reforms. The airline invests heavily in enhanced inspection procedures, training programs, and safety culture improvements to prevent similar failures. The FAA revises certification requirements for critical single-point failure components, mandating more rigorous inspection intervals and fail-safe design features. The jackscrew lubrication schedule returns to manufacturer-recommended 650-hour intervals. Federal prosecutors ultimately decide against criminal charges, but the civil litigation results in substantial settlements for victims' families. The crash becomes a landmark case in aviation maintenance accountability. The investigation exposes the dangerous trend of extending maintenance intervals to reduce costs without adequate safety analysis. This practice, while economically attractive, proved catastrophically dangerous when applied to critical flight control components. Captain Thompson and First Officer Tansky's heroic efforts inspire enhanced pilot training for flight control emergencies. Their professional response under impossible conditions sets the standard for aviation emergency management. The 88 victims of Flight 261 are remembered through enhanced safety standards that protect millions of future passengers. Their tragedy ensures that maintenance cost-cutting can never again compromise the integrity of critical flight control systems.